All right, I'm going to do one more with the calculator, and then I will most likely um, just do the rest of them on paper and upload it. I won't do another video unless you just ask me to. So this will be the last video that I work with you. If you need more help, let me know. So here's how you would use the calculator. According to a study of U.S. adults ages 18 and over, the mean, okay, there's my claim. My claim is that the mean number of work days missed due to illness or injury in the past 12 months is 3.5 days. The mean is 3.5 days. You randomly select 25 employees. What is that telling me? My sample size is 25. And you find the mean number of work days for that group. That means that's my sample mean is 4 days. You assume that the population standard deviation, population standard deviation, that's how you know that we're doing a z-test. The population standard deviation is 1.5, and we are working with alpha at 0.1. But before I do that, it says use a p-value. So here is like an example where they're specifically asking us to use the p-value test, not the rejection region. So I'm going to go ahead and go back over here. The claim contains equality, so that means it's my null hypothesis. That means that my alternative hypothesis is the opposite of equaling 3.5, so it's not 3.5. That's the alternative hypothesis. Okay. Since the alternative hypothesis looks like this is a two-tail test. And if we were drawing it, we would have shading on both sides. But we don't need to draw it because the calculator is going to give us. It tells us to use a p-value. So remember, we're testing the p-value. Is it less than or equal to, or is it greater than alpha? That's what we're trying to figure out. And so we need a p-value, and then we know alpha is 0.01, and then we'll have to figure out what symbol goes right there. So this is a hypothesis test. So we're going to go to the stat button, and the third tab over is tests. So tab over to tests, and you're going to be picking from either z-test, t-test, or a one proportion z-test. And this is the section that we're on right now. This is 7.2. This is going to be 7.3. And then this one down here will be 7.4. Okay, so we're going to choose option number 1. It's a z-test. How did we know it was a z-test? Because we knew the population standard deviation. So we're going to press enter. Here's where you get to choose between data and statistics. We know the statistics of it, so I'm going to press enter and make sure it's highlighted. If it wasn't highlighted, if data was highlighted, then we would have a different piece of information. It would want to know what list is our data in, but we want statistics highlighted, so press enter. Now they want to know what is the number that goes with the mean of the population that goes with the claim or the null hypothesis. So for us, that's going to be 3.5. The population standard deviation is 1.5. The sample mean is 4. The number in our sample is 25. And what kind of test is it? They're asking us this so they can determine whether it's a one-tail, two-tail, or a left tail, right tail, or two-tail test. That's why they're asking this. So we're telling it that it's a not equal to, and they're going to understand that that means it's a two-tailed test. So I'm going to leave that one highlighted. I'm going to go down here to calculate, and it calculates it, and it gives me my test statistic. So if it asked for my test statistic, it would be 0.47. This is the p-value, so that's the area for this problem. So oh goodness, point 63. I don't even know what that is. I've never seen that before. 0.63 areas are normally four numbers. 0.6374. Okay, but we can see already that this number right here is greater than 0.01. 63 cents is much bigger than 1 cent. So that means if you go back and look at our thing way up here at the top, when it's greater than, we fail to reject. Okay, so we are going to, P was greater than, so we fail to reject. And remember, that's always H sub O. We fail to reject H sub O. So now we need this little memory helper. So for this situation, my claim was the null hypothesis. My claim was the null hypothesis. So I'm in this column right here. And I failed to reject the null hypothesis. So this is going to be the one that I pick, this one right here. So I'm going to write this. There is not enough evidence at 1% significance level to reject the claim that the mean number of work days missed due to illness is 3.5. That 3.5 is the average number of sick days missed due to illness. I mean, does that last part of that sentence have to be worded exactly like that? Absolutely not. What am I looking for? I am looking for there is not enough evidence at 1% significance level to reject. That's what I'm looking for. Okay, I do want to show you real quick that if this had not just been use a p-value, if it had been draw the picture, then you could have gone that method. So you go to test, you go to z-test, option number 1. All of this information is going to stay in there. So it's all, oh, hold on. Did I not put in 25? Oh, clear. I may not have gotten the right answer. We'll see. I'm going to do draw this time, but it'll give us the same values. So the z value this time is 1.67. The p value is 1.0956. Okay, so I need to adjust this. This one was wrong, but I don't think it's going to change my answer. The p-value is really 0.09. So 0.0956. This thing right here is still bigger than this one, so I'm still going to fail to reject, but it makes sense. I'm going to go back and do it one more time just to make sure I didn't make a mistake. So I'm going to do stat. I'm going to go to test. I'm going to do z-test. It was 3.5, 1.5, 4, sample size is 25. Okay, and I'm going to go down here to calculate, and the z value is 1.667 and the p value is 0.095. Okay, so that is the correct information, and that is the correct conclusion now that I got the correct p-value. But I thought the draw feature of that was really cool because it would help you see. Well, first of all, it's going to help you know that it's a two-tailed test. It does plot your test statistic, but it does not plot your I keep losing that word because I'm so tired. The other one, not the test one, but the critical one. It doesn't plot your critical one. So you have to be sure to know how to plot your critical one. All right, that's how you use a calculator.